Today we're talking about triangle congruency. Our objective is to review side, 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 angle, angle, and angle, angle, side congruency postulates learned in Math 1 and use them to write proofs. So our first example is a postulate. It's the side, side, side congruence postulate. If we have three sides that are all exactly the same as another triangle, then these two triangles have to be congruent. This is the side, side, side postulate. Now, postulates are things that we do not need to prove. Our next one is the side, angle, side congruence postulate. If two sides and the included angle of one triangle are congruent to two sides and the included angle of a second triangle, then the two triangles are congruent. So for example, I have this side is the same as this side, and this side is the same as this side, and the angle in between are the same. So we have two sides and an angle in between. So make sure that if it's side, angle, side, that angle is right between the two sides that are congruent. And this is the side, angle, side congruence postulate. Our next one is the angle, side, angle congruence postulate. If we have two angles that are the same as two other angles on another triangle, and the side included in between those two angles are the same, then the two triangles are congruent by the angle, side, angle congruence postulate. Our last one is not a postulate, it is a theorem, and we can use the postulates to be able to prove this. So if we have two angles that are the same as two other angles in another triangle, and we have a side that is not in between those two angles, this would be two angles and a side not in between the two angles. So this is angle, angle, side. That's different than the angle, side, angle. So if it was angle, side, angle, the side would be right in between these two angles. But if we have our two angles and it's a side not in between those two angles, that's angle, angle, side theorem. Now we're going to use our congruence theorem, our angle, angle, side congruence theorem, to fill out the reasons in this flow proof. A flow proof is a flow chart where we write a statement and the reason inside the flow chart, and that has arrows to indicate other things that come from that. So we're going to start. We know that angle A is congruent to angle X. Here, those two angles are the same. That is given. Angle C is congruent to angle Z. That is also given. And BC is congruent to YZ. That is also given. Now, because angle A is congruent to angle X and angle C is congruent to angle Z, we have two angles that are exactly the same. Now, we learned earlier that if we have two angles that are exactly the same, the third angle has to also be the same because all triangles add up to 180 degrees. And if you minus these two angles, they will be the same as minusing these two angles from 180. So B has to be congruent to angle Y by the third angles theorem. So now we have two angles that are the same here, two angles that are the same here, and then a side in between the two angles. So these are congruent by angle, side, angle postulate. We're now going to determine if there's enough information given to prove the triangles are congruent. If there is, we're going to state the postulate or theorem used. So let's look at number 2. We have two angles that are the same here, two angles that are the same here, and a side is in between the two angles, or directly in between the two angles. So this would be angle, side, angle postulate. Now, we need three things to show that triangles are congruent. The first one is angle, side, angle. We had side, side, side. We have side, angle, side. And we have angle, angle, side. Let's talk about the two that are not congruent. If I have three angles, those would not be congruent. And if I have side, side, angle, these are not necessarily congruent. Now, if we have three angles that are the same, let me show you an example. I've copied a duplicate triangle. So right now they are congruent. All of the angles are the same. However, if I take this and I resize it so that it is bigger, all of the angles stay the same. All three angles are the same. However, these two triangles are not congruent. One is much bigger than the other. Another example is if I have side, side, angle. Here's an example of side, side, angle. We have two sides that are exactly the same, and we have 3 and we have 4, and they both have a 42-degree angle. So both of these have two sides that are the same and an angle that is the same. However, these two triangles are obviously not congruent. So they could be, but it's not necessarily the same. So let's look at number 3. We only have two things right now. I have two sides here and two sides here. So I could either have side, 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 or side, angle, side. So I don't really see any way for these two sides to be the same. However, I am noticing that these two angles are vertical angles, so they are the same as well. So we have two sides with an angle in between the two sides. So these two triangles are the same by side, angle, side congruence. Number 4, we have two sides and an angle that is not in between the two sides. Now, I like to remember that we don't swear in math class. So this one is not a thing. So side, side, angle, can't swear. This is not enough information to say whether these two are the same. Number 5, we have two angles, but we need three things to show two triangles are congruent. I am noticing there is a line right in between. This right here is a reflexive line. It's kind of like a mirror image. Reflexive reminds me of reflection, and they share this line, so it's kind of like a mirror image, even though it's twisted a little bit. So this is the reflexive line. It's the same. I have two angles that are the same, and I have a side that is not in between. I have two angles that are the same, and the side is in between the two angles. So we have two sides with an angle that is right directly in between those two angles. So this is side, angle, side postulate. Number 6, I see two angles, and this one's very similar to the last problem in that this right here is a triangle. This is the reflexive line. Both of them share that line. It's going to be the same on both triangles. So this would be the side, side, side congruence postulate. Number 7, I see two things that are the same. We have two right angles. Right angles are 90-degree angles. And we have this side here that is the same. We need three things that are the same. So we also have vertical angles here. So we have two angles, and notice that side isn't in between the two angles. It's off to the side. So instead of angle, side, angle, this is going to be angle, angle, side. Now this is not a postulate. This is the only one that is a theorem, and we just proved that with that flow proof. Now we're going to be showing a whole bunch of different proofs here. We basically need to figure out if this is side, 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 angle, side, angle, or angle, angle, side congruence postulate. Given n is the midpoint of MO, let's start by writing that for our given information. N is, if it's right in the middle, then MN has to be congruent to NO, or ON. Now, if I look at this triangle, I have three sides that are the same. So I'm going to use side, side, side to prove these triangles are the same. Now this is a little hint that helps me. If I write down side, 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 and then I'm going to write the congruent statement here. Now I've written that N is the midpoint of MO. I wrote that in this first line because that wasn't a side or any of these sides, so I'm not going to write that there. But let's go ahead and write LM is congruent to PO and LN is congruent to PN on two of these sides. All of that information is given, so I'm going to write given on all of those. Now, this last one is a little bit tricky. I'm going to show that MN is congruent to ON. If I look at my congruent statement, I need to make sure that those go in the same order as they appear in your congruent statement. MN and ON are going to be congruent. And how do I know that those are congruent? Well, I'm going to go back up to this given information. N is the midpoint. Midpoint, it means it's right in the middle, which means each of these have to be the same. So I'm going to use the definition of midpoint as my reason. On the final line, I'm going to use my side, side, side congruence as my reason, and then I'm going to write what I'm trying to prove here. So triangle LMN is going to be congruent to PON by side, side, side congruence postulate. Number 9, we're going to just look at this figure, and we're going to just kind of figure out which congruence postulate or theorem we're going to use. We have an angle here that's the same and an angle here that's the same. Remember, we need three things to show that they are congruent. Now in this triangle, I have two angles here that are congruent to two angles in the other triangle. Now I see this reflexive line right here. If I look at this triangle, the line that is congruent is not in between those two angles. It's off to the side. So this is going to be angle, angle, and a side not in between those two angles. So I'm on my statements and reasons, I'm going to write angle, angle, side. And then at the bottom, I have my congruent symbol where I write my congruent statement. So let's start with an angle. We have angle L is congruent to angle N. I also have angle LOM is congruent to angle NMO. And both of those would be given. Now my side is a reflexive line right in between the two triangles. It's kind of a mirror image, even though it's twisted around, but they share that side. It's a reflexive line. Now when I label it, I'm going to look at my congruent statement. MO is, it's labeled OM and MO are going to be congruent. Now we're going to pull it all together and write our congruent statement. We're going to use this triangle theorem to write here, and I'm going to use my angle congruence here. And so triangle LOM is congruent to triangle NMO by the angle side congruence theorem. At number 10, we are given that QT bisects SP and SP bisects QT. Now that doesn't tell me anything is congruent, so I'm just going to write that on the first line and say that that is given. Next, I'm going to kind of look at my picture and kind of see why these two triangles are similar. Now, as I just look at the figure, I'm not seeing anything that's the same right off the bat. However, if I look at my given information, QT is bisecting SP, which means bisect just means it's going to cut it in half. So if I took QT, SP is going to cut QT in half, and QT is going to bisect SP, which is cutting that in half. So if each of these lines are cut in half, these two have to be the same, and these two have to be the same. So that would be two sides. I also am seeing some vertical angles here, and so those two angles in there have to be the same. So we have two sides and an angle that's right in between those two sides. So this would be the side angle side congruence postulate. So when I'm writing the proof off to the side, I'm going to write side angle side congruence. Now I'm going to say, let's start with QR and TR. Notice if I look at my congruence statement, QR has to go with TR. And the reason is because SP is bisecting QT. So this word right here is why those are the same. Bisect means it cuts in half. So we're using the definition of bisect to tell that those two pieces are the same. Now we need to do our angle. Our angle is this one here. And those are the same because they are vertical angles. So my reason is vertical angles. And I'm going to start with QRP. QRP goes in this order, so it's going to be congruent to TRS. Our next one is the last side. We've done QR and TR. Our last one is going to be PR and SR. And if you aren't sure, you can always look at your congruence statement. PR goes with SR. And the reason for that one is also the definition of bisect. SP has been bisected by QT, and QT bisects SP, and so these two are congruent. And now we're going to write our congruency statement. So to do that, we look at what we're trying to prove, and that's going to go in this area. And then the reason is going to be this part right here, side angle side congruency. On number 11, let's look and see if we can figure out why these two triangles are congruent, and then we'll kind of write an outline of what we're going to say. AB is congruent to CD, so they have some little ticks right here saying those two lines are the same. We need three things that are the same. Now I see a reflexive line right down the center. The AC is going to be congruent to CA, and then I need one more thing. Now the only other information that I'm given is that AB is parallel to CD. If these two lines are parallel, then we have a transversal here, and the transversal alternate, if those lines are parallel, the alternate interior angles are the same. So when I look at this, I think that these are going to be the same because we have two sides with an angle in between, and so this is going to be side angle side congruence. So we're going to use that. We're going to write our given information. I'm not going to use this part to write down first because that is a side, and I'm going to put that with my side here. But I am going to, before I start, I am going to write that AB is parallel to CD. And the reason for that is given. Okay, now I'm going to take and I'm going to write side, angle, side, and then I'm going to have my congruent statement. Okay, so let's start with the given side. AB is congruent to CD, and that is also given. Now for my angle, if I have if these two lines are parallel and we have a transversal, then angle BAC is going to be congruent to DCA, and that would be because they are alternate interior angles. So I'm going to go ahead and write alternate interior angles. And so angle BAC is going to be congruent to angle DCA. For the last side, I'm going to say that AC is congruent to AC, and that would be because of the reflexive property. It is a reflexive line. Now we're going to go ahead and write our final congruency statement. We can find this here. Triangle ABC is congruent to triangle CDA, and that would be because of side angle side congruence. Okay, number 12, let's figure out why these triangles are the same. We have BC is congruent to DC, and we have AC bisects BCD. Bisects means it cuts it in half. So if I have angle BCD and I cut it in half, that means that these two angles have to be the same because we're cutting that angle in half. So those two angles are the same. And then I also see a reflexive line here. So this would be two sides with an angle in between. That would be side angle side congruency. Now I want to use this piece as one of my sides. So I'm going to just write this down as given before I start. And then I'm going to write side, angle, side congruence. Now my first side is given. My angle would be BCA is congruent to DCA. And the reason for that would be the definition of bisect. Bisect means we're going to take this angle, AC is cutting it in half, it's bisecting it, so each piece of these has to be the same. So that would be the definition of bisect. Okay, now the last side is this reflexive line. Now if you're unsure whether to write AC or CA, you're going to say, just take it on one, A goes to C, on the second one, A also goes to C. So we're going to say AC is congruent to AC, and that would be the reflexive property. Now we're going to write our final congruence statement. So we write this congruent statement here. Triangle ABC is congruent to triangle ADC. And the reason for that is what we wrote on this side here, side angle side congruence. Okay, so let's go ahead and talk about why these two triangles on number 13 are the same. C is the midpoint of BD. So here is C, here's BD. If C is the midpoint, the definition of midpoint means it's right in the middle. And so each of these pieces are going to be the same. AB is perpendicular. This upside down T means perpendicular, which means it's a right angle. So AB is perpendicular to BD, and BD is perpendicular to DE. So we have two right angles, which would also be the same. I also see a pair of vertical angles. So these are two angles And then the side in between the two angles are congruent. So this is going to be angle, side, angle, congruent triangles. Okay, so let's go ahead and write this given information down. We're going to need to write all of that down. Okay, now we need one more thing before we go into our angle, side, angle, congruent. I need to establish that these are right angles. So we're going to say that angle ABC and angle EDC are right angles. And the reason I can say that is the definition of perpendicular. Perpendicular just means it makes two right angles. So now after that we can write our three angle, side, angle, and then our congruency statement. Okay, so we know that ABC and EDC are right angles and all right angles are congruent. So angle ABC has to be congruent to angle EDC because they are both right angles and all right angles. Our side, we know that C is the midpoint of BD, and so BC has to be congruent to DC. And notice if you're unsure the order, look at your congruent statement. BC and DC go together. And the reason for that is the definition of midpoint. Now our last one is another angle. This angle here is congruent to this angle here because they are vertical angles. So I'm going to go ahead and write vertical angles. And we'll say BCA is congruent to, now if I look here, I'm going to go BCA is going to go to DCE, or you can look BCA goes to DCE. And now we write our final congruency. Triangle ABC is congruent to triangle EDC. Our reason is right here, angle, side, angle, congruency.